better late than never. We just learned about enumerate. There we go, right? And we learned about range. Well, I got rid of the range, but we did learn about it. And we were doing linear search. All right. So, a couple of cool things we can do with lists. Because I'll give you a couple of operators we can use and some methods that are associated with lists. And when I say method, that should tell you oh, are lists objects? Yes, they're objects. And because they're objects, they have attributes and they also have methods. Attributes are the variables, it's the data, and the methods are the functions that you could tell the list to do stuff. The sum we've seen is append. I showed you that one, right? When I appended the list to itself, but really it was when I appended the list a reference to itself. So you can add lists together. If you add them together, all it does is concatenate them. Same idea as a string, right? Adding strings concatenates the strings, adding lists concatenates the lists. You can multiply a list with a number, and it'll just repeat the list that many times, just the same way as it worked with strings. And then here, we could do this one together real quick. If I've got A dot, we can see we have a bunch of methods. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. A bunch of methods associated with them. Cool, right? Cool. And if you want to know anything more about them, just hover. Remove the first occurrence of value. Raise value error if value is not present. All right, cool. So there's a bunch of methods with lists. Now, unlike strings, which are immutable, lists are mutable. We can change what's in there. And I'll give you an example. So if I say b equals a at index 2, print b, what do you expect to see? What should be printed out? C, right? So we can access an element just fine. But remember, we could do this with strings too. But remember, the issue with strings is if I did something like this. Right? Strings wouldn't let me do that. It didn't allow for assignment like this. Lists, on the other hand, I'll just print out all of A, do let you. Lists are mutable. I've ranted about how programmers actually love when things are immutable. Mutability can be a bit of a problem. The exception kind of is with data structures. Data structures, kind of like the spirit of data structures is that there's data there and you can access, modify, and change it, and it has all these different states that you can put it in. That's kind of the point of them. Now, you can make data structures that are immutable, but we don't often do that. So it's common to have mutable data structures like this one. Cool. Yeah. Lists and loops, collection of things, for thing and collection of things, print them out. We saw that one already. If we do that, we'll see each thing on its own line. And if you are trying to remember, why do they all get on their own line? Because whenever you do print, print automatically adds a new line whether you like it or not. Yeah. And then we saw range. We saw that example a moment ago, right? Where for I in range 5, print I, we would see 0 through 4. So this is a quick and easy way to make a list do some number of things. And a couple of cool things about range, by the way, is for I in range 5, 100 by 10s, print. Range is actually pretty flexible, and it allows you to do a couple of neat things. You could say start at index 5, go to 100, but count by 10s. So I go 5, 15, 25, 35, 45. So it actually gives you a lot of flexibility, which is kind of neat. You don't need to specify this. You can do that, whatever. Start at 5, go to 100. you can go from 100 to -1, counting by negative tens. There you go. Now, why did I need -1? Well, it goes up to, but excluding the last number. So if I did 0, we would never see the 0. Maybe that mattered, maybe it didn't, but there we go. Cool. Pretty neat. This style here, this is the same, though, right? That for loop with the range and this while loop, very basic, very straightforward, same idea. And then this, I kind of spoiled it for you, but yeah, you know what? For fun, write this function. Write a function beer on wall that prints out n bottles of beer on the wall for all n from 99 down to 0. The function must use a for loop with the range function built in. Okay? And if you have an issue counting backwards, just think about what I said not 1 minute ago. Here's my incorrect version, but it might give you a bit of a starting point. But this is, of course, wrong. You got to count down. You start from 100, right? Raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. Okay, have fun. All right. Who did it this way, which is not really what I intended, but who did it this way? Did anyone do it that way? You did it that way? Yeah? So what did I do? Well, n went from 0 to 100, and then I printed out 100 minus n bottles of beer on the wall. Right? So the first time through the loop, what's 100 minus 0? 100. 100 minus 1, and so on, right? So that would work. But this isn't really what I had intended. I wanted you to, now this is fine, this is perfectly fine, but I wanted you to say start at 100, go to, I guess 0, and count by -1. That's what I wanted. And then that'll work, right? We go down all the way down to 1 bottles of beer, and then we're sad. That's kind of how I wanted you to do it. Cool. There we go. Any questions about this one, though? You may notice, too, that like the pattern for range is the same as slicing, right? Remember how with slicing, except we use colons, where the first number would be like where you start, second number is where you end, and the third number is like what you're counting by? Same thing with range. Cool. And then finally, we talked, this is what I showed you already, but finally, like, if I wanted to find the index of using a for loop, we're in a bit of a pickle, because the for loop doesn't give us the index by default. It gives you the thing, right? So needle element, so needle haystack, for element in haystack, element will be each thing in the collection of things, right? But it's not the index. So how do we fix it? Well, we could use range, like I showed you, range of the length of the list, and then use that index. Okay, great. But we could also, right? Haystack length is the length of the haystack. For I in range, that, and then I will be 0 through whatever the length is, right? So we could do it that way. That's fine. It'll work just fine. But down here, and then here showing, to be clear, for I in range the length of another list, A, B, C, D, E, F, whatever, print I, and then another list at I, you see like that, right? Yeah? This shouldn't scare you. If it does, just slow down. That's what we see. But we have that special enumerate function, which will do that like for us. It's just like, it makes things a little nicer, right? So for I, an element, in enumerate another list, I will be 0, 1, 2, 3, whatever. Element will be the thing. And like I showed you, if we did another list at I, it would be the same thing as element. Okay? Let's do that one more time, just to make sure it sticks. And then, another list at I. Cool. Right? Remember? Why? Well, 0, first time through the list, 0 and A. So 0, A, and another list at 0 is A. 1, B, 1, B, and another list at 1 is B. So that's why it looks like that. Okay? You're all really quiet today. Does that mean this is really obvious and you understand, or does it mean you're spooked? Oh, then silence is you're happy, I guess. All right, cool. Now, let's do an activity. Do the beer on the wall activity. Just do it, but write it on paper and hand it in to me. Have it in before, I'll give you plenty of time. Have it in before 11:20. You have 13 minutes for this one. Plenty of time.